So in this video we will check out part A of number 6 from the 2012 AB exams. This is a non-calculator question, and they say that a function is going to hold from 0 to 12 and that a particle is moving along the x-axis on this during this time frame. The velocity of the particle is given by this function, so we don't have a position function to work with here. We have a velocity function, something to keep in mind as we answer the pieces of number 6 here. And the particle is at position x equals -2 at time t equals 0. Part A, it says from 0 to 12, when is the particle moving to the left? Well, the particle is moving to the left when the rate of change of its position is negative. And the rate of change of its position is velocity. So what we basically need to figure out here is when is velocity going to be less than 0? So basically, if we make a sign chart for our velocity function, we're going to be able to answer the question in part A here pretty quickly. So we want to set v of t equal to 0. And if we set v of t equal to 0, that would amount to cosine of pi by 6t being equal to 0. So what we typically do in situations like this is we break out the unit circle and we try to use it to help us with our trig ratios. What I notice here is that we have more than just a variable inside this. We have a coefficient as well of pi by 6. So what I'm going to do initially is I'm going to say, let's figure out when cosine of some blank equals 0. Well, on the unit circle, cosine is going to correspond to the x-coordinate at any point that you sit at. And the x-coordinate at this point on the unit circle is definitely 0. So the angle that could be here could potentially be pi by 2. It could also be 3 pi. The x-coordinate on the unit circle is 0 at that location. My fault, not 3 pi, but 3 pi by 2. And if we continue to go around the unit circle here, we could get back to this point, and that would be an angle of 2 pi here, or 4 pi by 2. So this would be 5 pi by 2, 7 pi by 2, and so on. These solutions go upward. They actually go backward too. There are negative values, like we could start here and work back to this, but we're supposed to only be dealing with positive t values. Now I've listed enough angles here that we're hopefully going to be able to figure out our answer pretty quickly. So let's see. We didn't just have a variable here. That's why I rewrote this equation. We said the values that would make this equation true are here. We want to figure out what values make this equation true. So when is pi by 6 times t going to be equal to pi by 2? So I'm basically equating what we have inside the cosine function here from our velocity function with what we found one of the solutions to this equation to be. And if we multiply both sides of that by 6 and divide both sides by pi, what we get is we get t equals 3. Right? Multiply by 6 and you're going to get 3 pi, but then divide by pi and you're just going to be left with the 3. If you do a similar thing with the 3 pi by 2, set 3 pi by 2. Let me do it in the same order here. So let me set what's inside the cosine function there, pi by 6 times t. Let me set that equal to 3 pi by 2. Taking a similar approach, let's multiply by 6. Well, when we multiply by 6, that's going to give us 18 pi over 2, or 9 pi over 2. But then divide by pi, what we end up with is we end up with t equals 9. So t equals 3 makes the velocity 0. T equals 9 makes the velocity 0. I think if we check this one, the 5 pi by 2, which we should probably consider, I think it's going to put us outside this range. Let's just double check to be sure. So if we set pi by 6 times t equal to 5 pi by 2, multiplying by 6 is going to give us 30 pi by 2. 30 divided by 2 is 15 pi. Divide by pi, yeah, we get t equals 15. So the only two times between 0 and 12 when the velocity function has a value of 0 is at 3 and at 9. So if we're trying to build a sign chart for this velocity function that holds for the values from 0 to 12 for t, we know the only time that the sign of velocity can change is when it first crosses 0. That only happens at 3 and at 9. So if we look for the sign of v of t on this interval, on this interval, and on this interval, we're going to be able to answer our question pretty quickly. So between 0 and 3, what can you say about our velocity function? Well, if you take a value of t like 1, pi by 6 times 1 is pi by 6. On the unit circle, that puts us right here. Now, cosine of pi by 6 is going to correspond to the x-coordinate of this point. That's obviously a positive value. So we're going to have positive velocity values there. If we take a value in between here, like right smack dab between 3 and 9 would be 6. If we put 6 right here, we're looking at pi by 6 times 6. That would just be pi. That would put us at this point on the unit circle. Now, cosine of pi is negative 1. So our velocity would definitely be negative for all values of t in between 3 and 9. And then between 9 and 12, I think we are going to get another switch if we put a value like 10 in place of t. So if we put 10 in place of t, pi by 6 times 10 is going to be, let's see, 10 pi by 6, which would be equivalent to, what do we have? Well, if we reduce that, we're looking at 5 pi by 3. So let's see, where does that put us on the unit circle? This would be 3 pi by 3. This would be 4 pi by 3. We'd go 60 more degrees and end up over here in this quadrant to be 5 pi by 3. Another way to think of it would be to say 6 pi by 3 takes us back to 2 pi. If I go pi by 3 back from that, I'm basically going to have this angle right here be pi by 3. Any way you do it, you need to realize that you're looking for the cosine of a point on the unit circle that's about right here. And that's going to give a positive x value, so a positive cosine value. So when is our particle moving to the left? Our particle is moving to the left when velocity is negative. That happens on the interval from 3 to 9. So we're moving to the left on this interval. And that's it for part A.